In this video, we're going to be talking about midpoint sums. So we've looked at using left and right Riemann sums to approximate the area under a curve. Here, I'm interested in finding the area under 3 minus square root of x from 0 to 4. And so with, say, left Riemann sums, we'd say, okay, we want n equals 4 subintervals. It looks like that subdivides quite neatly. We've got one. Each rectangle has length of 1 unit. So I can take, okay, I'll start on the left side of this first subinterval, trace where my y value is, that's up at 3, create a rectangle like that. Here for my next subinterval, trace up to where my graph hits at my left endpoint, trace over and down. Do that for all 4 of my subintervals, and then find the area of each of these rectangles, add them all together, multiply by the width of all the rectangles, and that gets me my approximation, my Riemann sum. We could do the same thing for right Riemann sums. I would just look at my right endpoint. So my height here would have been somewhere over here instead of up here at 3. So left and right endpoints, those are both convenient choices. They aren't the only choices that we could make in order to determine our rectangle heights. Sometimes it's popular to either maybe use the smallest y value or the largest y value on each interval, just so that we maybe would be guaranteed an underestimate and overestimate. The choice that we're going to focus on right now is going to be my midpoint sums. We're going to look at the midpoints. So here, if I look at my interval from 0 to 1, that midpoint here would be 0.5. I could trace up and look at my y value here at 0.5. Look to either side here and use that area for my first rectangle. Here, my second midpoint would be at 1.5, so if I trace up over here, we'd be looking at this area right there. Keep on going, 2.5. That would be roughly that. And then over at 3.5, we would have that rectangle there. We could add all of those together and get an approximation for our sum. So let's do that. So it looks like I'm substituting in 0.5, 1.5, 2.5, 3.5 to get used to the notation a little bit. So we had our interval endpoints, like over here we had x sub 0 equals 0, x sub 1 equals 1, etc. 2. X sub 3 equals 3, x sub 4 equals 4. Those are still our interval endpoints, but if we want to write down what we're plugging in, one way of denoting that would be to say x sub 0 star. So in this interval starting with x sub 0, the point that I'm actually plugging in is 0.5, and then we'd have x sub 1 star would be the 1.5, etc. X sub 2 star would be 2.5, and then we'd stop with the point that comes in our interval starting with 3, so x sub 3 star would be our last one, and that would be 3.5. And then if I want to find my sum, I need to substitute all those in and add them together. So we would look at f of 0.5, 3 minus square root of 0.5, that times delta x. Here my delta x is, as established, going to be 1. Delta x. And so that times 1 plus 3 minus square root of 1.5 times 1, 3 minus the square root of 2.5 times 1, and then 3 minus square root of 3.5, that times 1. Plug all of that into a calculator. Our final result is going to be about 6.616181. That would be my midpoint sum with 4 subintervals. It would be good to get a general formula for this like we have for Riemann sums. So I'm just going to sketch out another interval over here. And so if I want to look at my x sub I star values, the values that I'm plugging in, so I'm starting with looking at my sum on an interval a to b. B is going to be my x sub n, a is going to be my x sub 0. I have my various x sub 1, x sub 2, x sub 3, and then all the way up to x sub n minus 1. So my midpoints are right in here. So I know that this gap here is of length delta x. If I want to get from A to my midpoint, so my x sub 0 star, instead of jumping all the way to x sub 1, I want to jump half that distance, so I take A plus half of my delta x. Now for my x sub 1 star, this point right here, I'm going to again start at A. I'm going to jump over by delta x to get to x sub 1, and then hop over by another half of delta x to get from here to here. X sub 2 star, follow the same procedure, start at A, make 2 hops of length delta x to get me to x sub 2, and then add on another half hop to get me to x sub 2 star. So if I want a general formula for that, x sub I star, again, start at A. I'm going to make I hops and then another half one. I can factor that out a little bit, I plus 1/2 times delta x. And now if I want my midpoint sum with n subintervals, I started with the midpoint of my 0th interval the way I denoted this, so I'll start with I equals 0. I'm going to end with this midpoint of my n sub n minus first interval, so like this would have been x sub n minus 1 star. So I'm going to stop at n minus 1 here, and then substitute in all of my x sub I stars times delta x, which if I want to write down what my x sub I stars are, this is going to look like the sum from I equals 0 to n minus 1 of f of a plus I plus 1/2 times delta x. After I plug in all of those, I would multiply then by my delta x again, and that would get me my sum.